Welcome to our mathematics class. We are continuing with equations, and here we are going to look at questions that arises from geometric part, that is the geometric equations. Earlier on in our previous lesson, we looked at the equations with numerals or with the unknowns on both sides, and part of those questions can be found when we are looking at geometric equations. Now, I want us to consider the following diagrams, and then we shall solve the diagram by looking at solving the values of the unknowns and finding the values of the prenumerals in the equations. In this question, we have been asked to find the values of the prenumerals, and the question here is on angles. Before you solve this question here, you need to have the idea about angles which you learned in the previous year. And when we talk about angles, we have got those angles which are on the opposite. And we normally say that opposite angles are always equal. For example, if we have this angle as angle A degrees, then the opposite angle will also be A degrees. Therefore, if this is the case, then it means that given the angle this side, you can be able to find the other one. And the angles that lie on the same straight line will be 180 degrees minus the unknown prenumeral, simply because it is always known that a straight line adds, the number of angles adds up to 180 degrees. So for this particular case, we must know that opposite angles are equal. So the fact that we have been given one of the angles as 6x minus 5, and another angle we have been given as 4x plus that 5, we need to bring in the idea of opposite angles and the idea of equivalent angles, equivalent equations to solve this. So for us to find the values of the prenumeral, which is the value of the x here, we shall have to show that the following behavior can be seen right here. Six x minus 5 is equals to 4x plus 35. This is true because 4x plus that 5 is for the opposite side or opposite angle of 6x minus 5. So this statement is true because these are opposite angles. And therefore, if we equate this, we can find the value because they are asking us for the value of the prenumeral. So we can simply find the value of the prenumeral by simply coming up to do what? To do the addition, and then we solve. So we have x on both sides. So the first thing, eliminate here 4x, and also eliminate here 4x. 6x minus 4x is 2x. On the other side, 4x minus 4x is 0, so we shall remain with a 35. That is what we have. So we have 2x minus 5 is equals to 35. Our interest is to solve. So we subtract, we are subtracting 5, so we add 5 on the right, on the left, and also add 5 on the right, such that this becomes 2x minus 5 plus 5, we remain with 2x is equals to 35 plus 5, which gives us 40. The next step, we shall divide by 2 and divide by 2 on the other side. We remain with x is equals to 40 divided by 2, which is 20. So we have been able to find the value of x as 20, and we can always go back and confirm or check our answer if it is correct or if it's not. Take x is 20 and replace it there. You'll find that this one will be x, 6 into x, and x is 20 minus 5. 20 times 6 is 120 minus 5. This one will give us 115 degrees. That is the size of that angle. But is it true for this other one? Let us also confirm. 4 into 20 plus 35. 4 times 20 is 80, and 80 plus 35 is 115. So we have confirmed that the two directly opposite angles are equal. So solving equations can also be applied in geometry. Let us look at another question related to geometry, and then besides these angles, there are also other areas where we can apply this geometry. In this question, again, find the value of the pronumeral, that is k, given the diagram that we have and the angles we've been given as stated on this particular, in this particular diagram. Now, looking at this, first ask yourself, what type of a shape is this? What type of a diagram is this? You'll find that this is a good example of what we call a parallelogram. A parallelogram. So this is when you look at this diagram, it's a parallelogram, and in a parallelogram we normally say that two opposite sides are equal and parallel, then two opposite angles are also equal. So in this case, we are not looking at sides, but we are looking at angles. So which means the two angles that we've been given are what? Are equal. So for us to solve this particular question, we shall equate the angles. And on equating the angles, we shall say that six, 3k plus 4 is equals to 6k. This is a k minus 32. 3k plus 4 is equals to 6k minus 32. Now, we have equated, we have pronumerals on either side. We bring in the ordinary approach of approaching questions now of this type, and now that will mean that we shall have either we choose to swap is okay, but we can work from any other direction. So let us subtract 6k here, and we also subtract 6k here. So 3k minus 6k will give us minus 3k. Minus 3k and then plus 4 is equals to 6k minus 6k is 0, but then minus 32. So we have minus 32 coming in there. Then from here, so what we find that what we have, we first removed 6k from this side, and that's the time we have, that's how we are getting this, this 6k is removed, we remain with 32 this side, and then when we subtract 6k here, it is 3, which is positive, minus 6k, which becomes minus 3k. Now, we need to now work out and remain with k, so we shall subtract 4 from this side and subtract 4 from that side. So this one will be minus 3k is equals to minus 32 minus 4, which is minus 36. Then you will come, because we want to have k as a subject, we divide by minus 3 and divide this side again by minus 3. Minus 3k divided by minus 3 is positive k. Minus 36 divided by minus 3 is a positive, and a positive of what? This will give us a positive of 12. So you now see that the value of k in this diagram is 12, and it's always good to confirm what we have, if it is right or if it's wrong, because this is a diagram that we require. So take k, we substitute here, the value we get here should be the same as the value we shall get at the end. So let's see. K is 12. Therefore, 3 into k, which is 12, plus 4 should be the same as 6 into k, which is 12 minus 32. 3 times 12 is 36. That is what we shall get. This is 36 plus 4, it gives us 40. Then 6 multiplied by 12 is 72, minus 32 will give us 40. So it is very true that what is on the right-hand side is the same as what is on the left-hand side. Therefore, k is our solution. That is, k is our solution, and its value is what? Is 12. So when we solve this, we find that k is equals to 12. So this can be applied in various areas, but for now, we meet any other question touching on geometry, we should be able to solve those questions using the equations like this. Now, that is it about the pronumerals on either sides. Now, I want us to get into equations with brackets. Now, equations with brackets, it's not the first time we are coming across this. We've had brackets several times while handling algebra, while handling other expressions. So we are only trying to add on that and see. This time we are going to have equations with brackets. We have an expression on one side which is showing to have brackets, but it is equated to another equation. So when you talk about equations with brackets, we mean actually equations like this. This is an expression which is factorized. It is in bracket. But the moment we put an equal sign and we equate it, then we shall be saying this is an equation. So we have an expression which is factorized, so it is in brackets. But the moment we equate it to a certain number here, then it means that we are able to find the equation given the brackets. So what exactly are we trying to say here? Now, normally it is easier to solve equations which are in brackets by expanding them. And to expand equations, we use what we call distributive law. And the distributive law, as you have always seen, it is you multiply what is outside with everything in the bracket. That is 4 times x and 4 times 2. So we need to know the following while handling equations with brackets. First, you must know about the distributive law. And just to remind ourselves what distributive law states, if we have a question in bracket like that, distributive law tells us it is A times B plus A times C. So it will be A, B plus A, C. This is an expanded form of this, and that is distributive law. For example, 3 into x plus 4. If you are working out this, then you'll find that using distributive law, it is 3 times x, which is 3x, plus 3 times 4, which is 12. We have expanded that. So we need to know this. Still on distributive law, if at all we are dealing with a factorized form of minus, that is A into B minus C, then the distributive law will state that this is AB, and then the sign here, look at it very carefully, it will be minus AC. Taking an example here, if we have 4 into B minus 2, the expanded form of this will be 4 times B, which is 4B, and then 4 times minus 2 is minus 8. So this one is the expanded form of this particular question. So for us to work out with the questions in brackets, we must know the distributive law. The next thing we need to know and be comfortable with working is what we call like terms. What is this that we are calling like terms? When you have those terms, that is the pronumerals in an expression and the pronumerals are of the same letter, or we say that they are alike. For example, this is an expression. In this expression, 5x plus 10 plus 7x. The terms with the same pronumeral are taken to be called like terms. So like terms are those terms which have the same pronumeral. So this is 5x, this is 7x. So they can be brought together. You can add them together. They can be simplified. So for this case, it will be 5x plus 7x, which is 12x. And finally, we want to say this, we must also observe this. I've noted this because it combines both part 1 that we have seen about distributive law and like terms. So we are saying this. All equations involving brackets can be solved by first expanding. And to expand, which law are we using? Distributive law. After expanding the brackets, you collect the like terms. That's what we've seen. We should know how to expand, and we should know that the terms are alike, and we collect them together. So let us now come and apply what we have gone through and start solving questions related to equations with brackets. Solve the following equations by first expanding any brackets. And the question is 1, we have 3 into p plus 4, close the brackets, equals to 18. And b, we have minus 12 or negative 12 into bracket, we have 3q plus 5. And this one is equals to minus 132. 3 minus 12 into 3q plus 5 is equals to minus 132. So we've been asked by first expanding any bracket. So we must expand any bracket. So first part here, the first question, we need to expand this using distributive law. 3 into p plus 4 is 3 and p gives us 3p. Then plus 3 and 4 gives us 3 times 4, which is what? 12 is equals to 18. This is now ordinary linear equation that we can easily solve. So this we shall subtract 12 here and subtract 12 there. You will remain with what? You will remain with 3p is equals to 18 minus 12, which is 6. Then we divide by 3 and divide this side by 3. What remains is a p is equals to 6 over 3, which is 2. So we have actually 2, and we started by expanding the brackets, and we have been able to access our solution or solve our equation by finding the value of p. So p is equals to 2. We can always check by going back. Second question. Minus 12 into bracket, we have 3q plus 5 is equals to minus 132. So the very first thing is to expand the brackets. So this one, using distributive law, minus 12 multiplied by 3q will give us minus 36q. Then minus 12 multiplied by positive 5. In integers, while multiplying, a positive and a negative will always give us a negative. The product of any two opposite mathematical operations, they'll give us negative. So minus 12 minus 5, the product will give us a minus. So this one will be minus 60. 12 times 5 is 60, so that is minus 60. And it's equals to minus 132. Now we go ahead, we have to solve. So we shall add 60 here and add 60 here. So we shall remain here with minus 36q. And the other side, minus 132 plus 60. That one will give us minus 72. Next step, we divide by minus 36 and divide this side by minus 36. Minus 36 divided by minus 36 will give us a positive. So with this one will give us a positive q is equals to minus 72 divided by minus 36. This one goes there twice. So you find that the value of q is equals to 2. The procedure is very, very important. The bracket first, expand them, then move ahead and solve. Now, let us look at another question, but this time it has brackets, but we have the pronumerals on either sides. So we have these questions. I said we have the brackets, but some of them have the pronumerals on either sides. And this other one, we have got now additional terms, so the terms are more. So we want to see how we can come up and collect like terms. And this one we want to see how we shall have to open the brackets from both ends and then work out as we solve. So the first question is asking us to solve 4 into 2x minus 5, then plus 3x is equals to 57, and 2, it is 2 into 3k plus 1 is equals to 5 into 2k minus 6. So looking at the first one, this one requires us to be able to collect like terms given various terms. Distributive law will allow us to say 4 times 2x will give us 8x. 4 times minus 5 will give us minus 20. Then plus 3x is equals to 57. Bring the like terms together. This will be 8x plus 3x minus 20 is equals to 7. 8x plus what you are calling 3x. When you add 8x and 3x, you will find this is 11x minus 20 is equals to 57. So this is the case here. We'll go ahead because we want to make x the subject. So we shall add 20 on both sides so that we have 11x we shall have 11x remaining because minus 20 plus 20 is 0 is equals to 57 plus 20, which is 7. At this level, we divide by 11. Divide by 11, you find that x is equals to 7. So the value of x has been found to be 7. We have solved this equation. We expanded, we collected like terms, and we systematically arrived at the answer x is equals to 7. On the other side, what we have here is simply a question that has brackets on both sides. So we are going to apply distributive law on either sides, that is the left-hand side and the right-hand side. So from this, the distributive law will give us 2 times 3k, which will give us 6k, plus 2 times 1, which is 2, is equals to 5 times 2k, which is 10k, minus 5 times 6, which is what? 30. That's what we have. So it follows that we subtract 10k on this side, subtract 10k on this side. 6k minus 10k is minus 4k. Then plus 2, and the other side, k has gone, that is k minus 10k is 0, so we remain with 30k. Subtract 2 both sides, so you will have minus 4k is equals to minus 30 minus 30, minus 30 minus 2, which is minus 32. Then we divide by, we have to divide by this, that is minus 4, and divide by minus 4. Minus 4k divided by minus 4 will give us a positive k. Minus 32 divided by minus 4 will give us a positive of 8. So we find that k in this case is equals to 8. K is 8. So we've been able to open or expand brackets on both sides until we arrive at that particular question, about this particular answer after working on the two questions. Now, this issue of brackets keeps on changing, and at times you might meet a situation that is a bit challenging. So we shall look at other challenging options and see how we can solve them when we are given similar questions. Now, we are moving into a bit challenging challenging questions, you take note of this. We solve the following equations. We have bracket, we have again a term on the other side. It is a bit challenging because we have got so many expressions terms forming just one single equation. So such situation should not bother you, because the main thing is to reduce this particular equation until it becomes an ordinary simple linear equation that you can solve systematically. But first of all, make sure you observe the rules, as we said, of first expanding those brackets, then collecting the like terms after that. Now you systematically solve the equation. So for this, where we have the brackets, you expand. Where we have like terms, we do what? Collect. So this question, 2 times 3x will give us 6x. 2 times 4 is plus 8. Then plus 5 times 6x, that is 30. X, 5 multiplied by 7, that is 35, is equals to, we don't have bracket the other side, so we have 64x plus what? Plus 1. So we go ahead now and start collecting like terms. We can easily collect them by bringing them together. So this one is 6x, anything with x is here, which is a plus 30x, and then nothing else. We have plus 8 plus 35 is equals to 64x plus 1. As you collect like terms, 6x plus 30x will give us 36x. 8 plus 35, this one will give us 43. And we finally have the other side, 64x plus 1. We need to resolve this by removing or coming up with pronumerals on one side. So this time let me use the other side. Let me subtract here 36x so that we remain with a known on the other side. Subtract 36x. 36 minus x minus 36x plus 43, we shall have 43 here, is equals to 64 minus 36. This one will give us, I think, not 18 but 28. So 28x then plus 1. Now, looking at this, we have not finished because we need to solve and get the value of x. So we are going to have this side, we subtract 1 on that side, and also this side, we subtract 1. When you do that, you remain with 28x is equals to 42. We have reached here. This is a simple equation. We can continue from this other side here. Now, what we have, if I swap, it's allowed, it is still equivalent. We said we can maintain an equivalent equation even when we swap. So we have 28x is equals to 42. Now, here, we need to remain with x. Therefore, we shall divide here by 28 and divide here by 28, so that we have x is equals to 42 over 28. This x is in form of a fraction, and in fraction we always give our answer in the most simplified form. So we need to simplify this further. And for us to simplify this, the common factor between these two is 7. So by 7 here is 4. And by 7 up there you get it 6. Then by 2 here you'll get it is 2. By 2 it is 3. So x is equals to 3 over 2. I called this a challenging situation because the values of x now here is not a whole number, but it is a fraction. So we can have such challenging situations. It's not always true that we must get the answer or the solution as a whole number. We can also have the solution for x as a fraction. Looking at another one. This question solves the question m is equals to, solve the question m minus 2 in bracket m plus 1 minus 3 inside the bracket m minus 1 is equals to 2 in bracket 1 minus 4m. M minus 2 into bracket m plus 1 minus 3 into bracket m minus 1 is equals to 2 into bracket 1 minus 4m. So you'll notice that this time now I've introduced more of negative signs, but we still have to apply the same method and see, are we able to solve those numbers which have got more negatives? So, as we saw earlier on, the very first important thing that we normally use when we are working with brackets, there's something we call BODMAS, where we shall first deal with the brackets, and this is order of division, multiplication, addition, and subtraction. So here we cannot start dealing with any other thing. Look for the brackets and start working out or expanding those brackets. So I'll maintain m minus 2 times m. We are using distributive law. So this minus 2 will go with m as well as with 1. Minus 2 times m is minus 2m. Minus 2 times 1 is minus 2. Minus 3 times m is minus 3m. Minus 3 multiplied by minus 1 is plus 3. Then 2 multiplied by 1 is 2. Then 2 multiplied by minus 4m will give us minus 8. We have simply expanded where we had the brackets. The point that follows, we start collecting or bringing together the like terms. And what are the like terms here? We have m running across all through. Let us collect them and see how to move on. So this will be, if we rewrite m minus 2m minus 3m, then we come to a whole number, minus 2 plus 3 is equals to 2 minus 8m. I'm only rearranging, and said in rearrangement, as you collect like terms, it moves with its sign that comes before the term. There's a minus 2 here, it is here. Minus 3m, it is here. And then 2 remain. The other side we have minus 8m, it is there. So m minus 2m minus 3m. Now, minus 2m and minus 3m gives us minus 5m. m minus 5m will give us minus 4m. Or we would say m minus 2m is minus 1m, which is m. Minus m minus 3m is minus 4m. Then minus 2 plus 3 is plus 1. On the other side, we have 2 minus 8m. So we can choose to eliminate either from this side or the other side, but this time round, let us add 8m this side and add 8m this side. So that this side we shall have 2 minus 8m plus 8m is simply 2, and this side we shall have minus 4m plus 8m is positive 4m. 4m. So we have 4m plus 1. When you work out, we shall have to minus 1 here and minus 1 here. You made the 4m is equals to 2 minus 1, which is 1. We divide by 4 and divide by 4, then it implies that what will remain with which we are calling m is equals to 1 divided by 4, which is 1 over 4. Take note that the answer is in fraction and not a whole number. So we can always have solutions either as whole numbers, as mixed numerals, in proper fraction or proper fraction. So the knowledge of collecting like terms requires us to go back to the knowledge of positive and negative integers. So let us look at the last one about the challenging equations with brackets as we wind up this small topic. And this question I want us to bring in the coefficients outside the brackets this time. Let us make them negative and see how do they affect while we expand the brackets. Solve minus 5 into bracket 3p plus 2, close the bracket, plus 5 into 2p plus 3, close the bracket, is equals to minus 31. Now here, the distribution law will always be applied, but there is a different approach because what we have outside the bracket is a negative. So we need to observe that very carefully. Using distributive law, minus 5 multiplied by positive 3p should give us minus, and then multiply what we have, 15p. Then minus 5 times 2 is minus 10. This one is a plus because everything seems to be a plus there. 5 multiplied by 2p gives us 10p plus 15. And this is equated to minus 31. So all the like terms are on one side, so we have no problem with that. Let us collect them. We rewrite and have minus 15, p minus 10, minus 15, p minus 10. We want to rearrange first. Minus 15p, and then we have plus 10p, and then any other p, we don't have any other p, so we come to minus 10, and then plus 15 is equals to minus 31. So when you look at p, we recollect them now, minus 15p plus 10p will give us minus 5p, and then minus 10 plus what? 15 will give us what? Plus 5. You are very careful, that's what you are able to see. It is a plus 5 because we have minus 10 plus what? Plus 15. And the other side, it is equated to minus 31. So from here, we shall simply work on this. So I'll simply work on this by subtracting 5 on this side and subtract 5 on that side. When you do that, we shall remain with minus 5p is equals to minus 31. minus 5 is minus 36. So we divide by minus 5, divide by minus 5. And this one should give us P is equals to minus 36 over minus 5, which is simply 36 over 5, and it is positive. It is an improper fraction. If you want to write it as a mixed fraction, you can always do. But mostly, if you leave the answer as an improper fraction, it is also allowed. So these questions can be handled at any given time without any problem, as long as you know how to expand or open the brackets, as long as you are comfortable about dealing with the signs when you're multiplying positive and negatives. Now that is it for now. When we come into our next lesson, we shall be solving what we call simple quadratic equations. We have been dealing mostly with the linear equations, where we have been able to solve for the unknowns, but this time now we are going to advance from the simple linear equations, which only was having one unknown and there is no power on it, and go into what we call simple quadratic equation. Thank you.